Welcome everyone that's joined us so far. We're going to wait a couple of minutes before we start the presentation just to let everyone join. For those of you that just joined, it'll be another minute or two before we start. We're just letting people that have registered join the webinar. We know it takes a few minutes sometimes with GoToMeeting. Okay, good morning, good afternoon, everyone. I guess since a lot of you are on the East Coast and the Midwest, it looks like the attendees have kind of leveled off now, so we'll begin today's Data Engineering Workshop. This is hosted by both AWS and Mission. We really appreciate you joining today. First, I'd like to welcome you from Mission. Mission's a premier AWS partner. We work with many customers to help them accelerate their data journey into the cloud and help them find the power of data and analytics, AI and ML on AWS. Today, our host is Vanya, and she's many of your account reps there in Texas.
Yeah, thanks, Ryan. I appreciate it. I hope you all can hear me well. Welcome to our data engineering workshop. I'm delighted that you are here. It's going to be a fun 2.5-day journey. So I hope that you are sitting down and ready to roll. As Ryan said, my name is Vanya Artis. I am a district lead here at AWS. I've been with AWS for almost 4 years, and I've been lucky enough to say that my focus has been our Texan customer base. So my team and I essentially help support and enable our customers in the small to medium-sized sphere. And one of the specific areas we've actually tackled quite a bit in the last 2 years, and the requests have been wider and higher, is this question around data and data having gravity and how to think about data, how to monetize data, and it's really the reason we're here today. So what I'd like to do to start is introduce our speakers and presenters for today and for tomorrow. Ryan, if you could go to the next slide. Perfect. So let's just start with Lance, and we'll go round robin for a few minutes and get to know our participants.
Hey there, everyone. My name is Lance. So I'm a senior solutions architect at Mission. I've been with the company for about 5 or 6 years now, mostly in engineering and operations related roles. But these days I support the sales team and work with a wide array of customers to understand their business needs and goals and objectives and try to help find them solutions on AWS. That's my background. I'll send it over to Gandhi.
Hey everyone, I'm Gandhi Raketla, solutions architect from AWS. Been with AWS for the last 3 years. I work with all the AWS consulting partners, especially in SMB segment for the central districts.
Hey guys. Hey guys. My name is Avinav Banerjee. I'm a solutions architect with AWS. I work with a lot of our customers to understand and kind of map back their use cases and architectures to the services and kind of the solutions that we provide. Really excited to be here. I'll toss it over to my colleague Will.
Hi, good afternoon, everybody. My name is Will Jacobs. I'm a solutions architect supporting our customers that are headquartered here in Texas. So I work with Vanya's sales team very closely, and I see the attendee list. I see some names that I recognize, so we've got some of our customers here, which is great. I've been in AWS for about 5 years. I started at AWS as a DevOps architect for Amazon Game Studios, and then I've been doing solutions architecture here in our Texas district for the last 2 years. So we're very happy to have everybody here today.
Thank you. Thank you so much. Perfect. Thank you, Ryan. All right, so let's take a look at the agenda. So this is essentially what today looks for us. And as you've noticed by way of the registration page, we have 2 half-days set up for this particular event. I want to just draw I'm sorry, I want to draw attention to 2 things as it relates to the agenda. There will be some breaks built into the 2 half-days, but not many. So we would ask, because we will be moving through the content at a timed pace, that you be mindful of when the breaks begin and when the breaks end, and just try to the best of your ability to join on time. And then the second piece, as far as day 2 is concerned, if we go to the next page, Ryan, is that the mission folks who are helping support us, as you've noticed, this is a collaborative event. We're getting started early in the morning, 7 a.m. Pacific their time, 9 a.m. your time. So it will be a prompt start, and we hope that you will be able to join us at 9 a.m. the next day. So that's on the content. If you have any questions as far as the agenda is concerned or the content is concerned, feel free to please ping us just in the chat window. All right, so the next slide, I want to just take a minute to talk about our partner community in general. As I mentioned, you've recognized that this event is taking place with Mission Cloud. Mission is one of our premier partners. They've really been a trusted advisor to many of our Amazon customers. I've actively worked with Mission over the course of the last 4 years to help customers scale any number of their initiatives, whether that's a complete lift and shift or modernization or multiple initiatives that have taken place. Mission Cloud has been front and center and enabling our customers. They are one of several partners we tend to collaborate with on any number of our customers' initiatives. And the reason our APN partners come highly recommended is really that it allows you as the customer to recognize value on our services. It reduces the time to recognizing value in our services. And I think roughly 60% of all workloads touched by our partner community ultimately get launched successfully. They bring industry experience to the table, and we ultimately reduce risk by providing co-investment opportunities. So the net, in addition to all the things that you see on the screen, is that we help fund your projects appropriately when you lean into our AWS partner community, and we are very passionate about bringing our partners in to the customer conversations, because we do believe and see time and time again that it does provide value. And I do want to hear directly from Ryan, if you don't mind. Please tell us a little bit more about Mission specifically. What is y'all North Star, and how do you view the value you bring to our customers day in and day out? And we've got you on mute, Ryan. Classic rookie mistake. I love it.
Love it. Thank you, Vanya. Yeah, I just want to spend a quick minute or two on the Mission infomercial. Mission is one of the leading AWS Premier consulting partners and managed cloud service providers. So we're able to work with you wherever you guys are on your journey, right? Are you looking to figure out what the best architecture is for one of your workloads? Are you looking to roadmap? Are you looking to understand how to migrate into AWS? We can help you with all those pieces. As I said, we have the managed cloud services, so we can help you with all of your needs of maintaining your ecosystem as well as cost optimization. We have all of those capabilities in-house that are at your availability if you need them. I guess it doesn't work that way. And then as a premier partner, one of the things that happens is AWS validates our qualifications, and there's a number of different certifications and competencies that we hold. You can see the list here. I'm not really going to go into them, but that's showing that we've worked with AWS. They've vetted and validated our services along these lines so that you can be ensured that you're getting quality delivery when you're working with Mission. In today's data engineering workshop, this should be a fun time over the next 2 days. As you can see, we have lots of really great speakers. They're going to walk you through all the steps that it takes to get your data into AWS, to build some of those foundational pieces and create dashboards at the very end. So it's a pretty exciting workshop that's been put together for you guys. And why are we here today, right? Basically, Clive Humby kind of put this out there several years ago. Data is the new oil. Everyone's really looking at how can I take all this data, all the information that I have, and really do something with it and help accelerate my business. One of the metaphors that I usually like to use is kind of the iceberg, right? I'm sure you guys have all seen your C-suite, your bosses, they really just care about that pretty top of the iceberg, which is usually, some kind of visualization, some kind of dashboarding. But what they don't understand is in order for you to get there, you've got to go through a lot of steps, right? You got to get your data from wherever it is, whether it's, on-prem, coming from IoT sensors, or maybe you're subscribing to data sets that are out there, into your S3, and you've got to handle all of the data governance pieces, right? How am I going to store this data? Is there PII? Is there GDPR if you're working, outside of the US? How am I going to handle everything that's going on with my data as it comes into the data lake and be protected? And then once I have data, how do I change it? How do I transform it, right? How do I do those ETL steps to make it into something that my people on the end, whether it's the dashboards or the data scientists, want to use and push it into some kind of data mart, right? Your Redshifts or Aurora or something else. And then finally, you've got your ML algorithms that it could be running. You might have data scientists on your team that are building these algorithms that are going to be pushing those visualizations or pushing pieces to the customer. So what does that kind of look like at the end of the day? So here's kind of our basic lakehouse infrastructure, and many of the pieces that the team will go over the next 2 days. We'll really talk about these pieces. But you can see it ends up being pretty complex. At AWS, we all like to work backwards, so we always look from the right hand of the screen to the left to figure out what's the end goal, right? What is your customer, and all of us have customers, whether we're working in a business or whether we're a professional services organization. What's that end user looking for, right? Is it an application? Is it a mobile app? Is it some user or data scientist? And what are they looking for, right? The visualization piece or the machine learning, and how do you get there? So, today's sessions are really going to help you understand, how do I architect each of these steps to get to that final outcome that your customer is going to be looking for. So, it's really going to be an exciting 2 days. I've seen the content multiple times. I think you guys will really enjoy it. Great team that's presenting everything. So that's basically my time. We're going to start right in overview of the data lake by Gandhi, where he'll go over some of these pieces in much more depth than I just covered.
And before Gandhi starts, Ryan, I think one thing we missed from you is who you are at Mission and what do you do at Mission? And I think that's important. And I'll tell the audience in a moment why, but would you mind introducing yourself formally?
Sure, absolutely. Sorry. So I'm Ryan Reese. I run Mission's data analytics and machine learning practice. I've been working in the AWS space 4.5 years now, enabling customers, getting into the cloud, using machine learning. It's been tons of fun. It's like solving a lot of puzzles as we help these customers who, have just an idea and come to us of, how do we do this? We've done cool things with trains where you don't necessarily think about it, but in the winter time, trains have reverse positive brakes. So if your car's length's too long and it's too cold, the brake lines won't work and they can't carry all the train cars over, and there can be accidents. So we've done all kinds of really cool, fun projects. So,
Thank you. No, that's perfect. Thank you. And the reason why I wanted to make sure that the audience knew who you were is because in line with the Mission infomercial, I think it's really important to recognize that the team here does have a practice around analytics and data, and this is not Ryan's first time heading up this initiative. He's done this in multiple other organizations that have also partnered closely with AWS, so I think you guys are in wonderful hands, and the presenters too, as you saw for the next 2 days, really it's a collaborative effort between our organizations to bring forth insight around this topic. So we hope you enjoy it, and with that I will turn it over to Gandhi. Thank you.
Yeah. Thanks, Ryan and Vanya. Let me first share my screen before we get started. Where do I? Sorry, I'm just. Can you see my screen?
Yep.
Yes.
Okay, the first session, we are going to talk about the data lakes. What is a data lake? Why a data lake? What is the advantages, benefits of having a data lake? And what is the ecosystem in the AWS, the services around the data lake in AWS? And once we have the data lake, what are the different consumptions we can do with the data lake? So we'll walk you through each one of them. So before we get started, so basically the last 2 years has taught us that we can't predict the future, right? No one couldn't predict that the pandemic of this scale. But what we can do is we can put in a place the infrastructure and the tools required to adjust to this change. That's what a lot of our AWS customers has done. We have seen a lot of our analytics customers who has to navigate what has been a challenging year and helping them fight against this COVID-19 pandemic. So we have seen segments like travel, where the customers has to scale down rapidly when things got worse. And then we have seen the segments where healthcare and then e-learning education, where the customers has to ramp up at a greater speed than what they actually couldn't imagine in the past in this year. So we have seen both sides of that. I just want to call out two of the great examples by two of our customers, which is Wired Medical. Basically, during the peak of pandemic, when the demand for ventilators soared, this company found itself handling a manufacturing volume which they didn't imagine in the past. So to just give a sense, their order volumes rose by 20x. So they used to manufacture close to 30 ventilators a week, and then suddenly they're supposed to their requirement to manufacture per day increased to 600. That means 30 from a week is almost like jump of a 600 per day. And then being in a medical domain, each product has to go to meet the tight regulations. Even in urgent demand skyrocketed, they can't compromise on the safety of these devices. They cannot compromise on the compliance. So, what helped the companies like Wired help them to navigate this tough journey? Basically, Wire's newly modernized analytics platform built on Amazon S3 data lakes and then Amazon Redshift as the data warehouse. For example, their ability to quickly scale, then basically when the demand rose, they're able to quickly scale that. That actually increased their first pass yield. Basically, that measures the rate at which a product passed through the final test on the first attempt and are ready for distribution. So in near real time, the Wire is able to load the data into the data warehouse and the data lakes, and then also push it to the relevant spot of the production. So basically, if this pandemic would have happened maybe 3 years back or 4 years back, Wire might have to be prepared. Now, since they put in this tools and then process in place, they are well prepared for this pandemic, and they're able to withstand the kind of the scaling of their either infrastructure they have to do, their manufacturing, everything. They're able to do it easily because they are prepared for this kind of events. Something similar to Moderna, which is like one of the leading vaccine provider in the US, where they actually build their entire platform on S3 data lake, again in Redshift data warehousing to store all this mRNA sequencing data, all the trial data, the test data. So they're able to quickly launch the vaccine to all the public, which could save like millions of lives. So these are the two great examples, which tells us that one thing, like we can't foresee the future, but be prepared for it. how do we be prepared, put in the right tools and infrastructure which can actually withstand the unknown events, and then help them to navigate through this difficult journey. So what has changed in the past couple of years, right? So the data volumes are increasing at exponential rate. For example, just to give a sense, the National Football League has got 180 million fans worldwide. So over 90% of this NFL fans are watching these games either on a TV, online, or mobile. If you are a gamer or if your kids are playing the games, so basically Fortnite has got 125 million subscribers. So that's something like 15 times the size of New York. So they ingest millions, literally millions of events a minute, and then terabytes of data per day. And then Netflix is having more than 100 million customers. I don't have exact number, but pretty much 100 million customers. And then every time you pause a TV, you forward, you change the show, they're tracking in real time. Basically, Netflix is, because based on that, they're giving you, showing you the shows you want to see, that preference is changing. So all these things, what it means is that this data is explosion of data. That is, data is growing exponentially. Second important thing is that the new data sources. There was a times where we had some handful of enterprise applications, like you were having an e-commerce application, a CRM application, order management application, HR applications. Only these applications could generate the data, which will go to the central data warehouse. From there, we build the reports. But now the sources are increasing. You are having applications, you are having mobile apps, you are having IoT devices, you are having Fitbit, you are having Apple Watch, you are having pretty much any device which can connect to an internet, they are able to generate the data. That means the rate at which you are getting from multiple sources of data is increasing. And third thing which is changing is the diversity of this data. So it's no longer a structured data coming from an application, which could be a proper data which can go to a relational database in a table, columns, data type, length, everything is predefined, and then we can store the data. Today we get the data as a JSON, it could be a Parquet, it could be any other a free form text, right? Because when the data sources are increasing, when the data volumes are increasing, the data formats are also increasing. Other big change, like we are having many people using this data. There are different people, like you could have somebody who is a data engineer loading the data into the system, or it could be a AML machine learning engineer who is actually trying to make a sense of this data, who's trying to train the model based on this data, or it could be an app developer who is trying to show this data or display this data or provide insight from this data for an analytics user, who is building a dashboard to merge the data from multiple sources and make a sense out of it, right? So we are having many people, and when many people and many applications, like it could be mobile apps, it could be a dashboards, it could be a machine learning or AML models. So a number of applications which are analyze this data is also growing. So what was happening traditionally is not working today, right? So this is what, if you go back 10 years, 15 years back, this is how it used to happen. You used to have some isolated databases like a CRM database, an ERP, an order database, and these are all these transaction databases. They will feed this data into a data warehousing, and some kind of ETL happens there, and then you have some business intelligence tools which actually take the data, right? And then over a period of time, every enterprise started accumulating the silos of the data warehousing. There is one data warehouse for all this ERP, CRM kind of data, and then I have another data warehouse because now I'm having a new different IoT data is coming. I'm having web, mobile, social media coming. So now I have another data warehouse. So now there is no a single source of truth, and there is no single way to govern this. And then even if I want to add a new data source, a new data type, or a new type of data, like I'm a company, I'm going to acquire another company, they have a different set of data. How do I actually bring them into my data warehouse and build the business intelligence around it? That was a big challenge. This was a challenge what was there a decade back, where traditionally all the enterprises build this big data warehouses in silos, which are not connected, which are not talking to each other. And then it was difficult for them as the business is evolving to make a sense out of this data. Like because there are a lot of dependencies within the data. Like when I'm having an CRM data, maybe a sensor, a web data or social media data, or there are two data warehouses, I will not be able to really make out sense of the data. That's where a lot of the customers are moving towards a new type of model, which is called the modern data architecture. So let's spend a few minutes about what is this modern data architecture. That is going to be since the data lake sits in the center of this modern data architecture, what exactly is this modern data architecture? So basically, this modern data architecture, the first thing is that centrally we are having a scalable data lakes. We are going to talk more about the data lakes, what is the purpose of data lakes, and then why the data lakes, when to use data lakes. We'll talk more about them. But if you can see that in modern data architecture, the data lake, which sits in the middle of everything. And then the next thing is, we are moving from the time where we used to have only handful of relational databases, where like Oracle, SQL Server, IBM DB2, which were actually having all the transaction data or the master data, or the other data being even for analytics we had for everything. From that, we are moving towards using a broad and deep collection of purpose-built databases that provides both the performance and the scale required when the business scenario changes, right? Whether you want to put interactive dashboards, you want to do some log analytics, or you want to do some big data processing, or you want to do some data warehousing. We are moving towards from traditional relational databases model to a mix of a purpose-built database services. And third most important thing is that when you have so many databases, you also need to have a seamless data movement between these databases. Like I will have data ingested into S3, which I want to read, I want to store in the a data warehouse, and also I have some hard data I want to store in a NoSQL database. At the same time, I'm having data which is connected to relations. I also want to store in the graph database, and then I should be able to seamlessly move the data from each of these services. So there could be some IoT device ingesting the data from a sensor, which is coming through a stream, which is landing into some bucket. From there, this might be going to a NoSQL database, and at the same time, the same data might be required for a long-term archival, a historical reporting in a data warehouse. So you should be able to move the data seamlessly between these data sources, right? Because as I told, just to give you context, we talked about the changing nature of the data. You are having the data which is changing, where you are having multiple data sources, multiple data formats, and huge volumes of data, and we are having a purposeful database for each one of them. So the most important thing is that how seamlessly you can move the data from each of these services into between them, or into the data lake, or outside the data lake, or between them. That means I should be able to move the data lake, data from a data lake to a data warehouse, from a data lake to a NoSQL database, or from a NoSQL database to a data lake, or from a streaming database to a data lake, or from a log analytics to data lake, vice versa. So that is called a seamless data movement. The next important thing is that when you have so many data sources, so many databases, so many data format, the big challenge what is this governance aspect. Who should have access to this data? Somebody who is building a machine learning model should have access to the data which is required for a model, where maybe the data he is using is to train the model or test the model. Somebody who is actually looking into a real-time dashboard or analytics dashboard should have access to the data from multiple sources so that they can merge the data and then build. Or maybe some supplier, some other external customer of this company, he's also looking into some dashboard, then he or she should be able to see a limited amount of the data. Basically, the governance aspect is what, like, who can see what data, what columns I can show, what rows I can show, what should not be displayed, and then how to encrypt this data, how to decrypt this data. So we have a lot of aspects of security and governance comes here. So the challenge here is that when you have multiple databases, multiple data sources, how do you build the governance? Because you cannot build a one governance on a relational database, and then you have to build another governance model on a NoSQL database, one on data lake, one on data warehouse. It becomes too tough to manage, and then at some point it becomes unmanageable. So basically you need to have a unified, a central way to manage this data governance. And last but not least, one of the main advantages of choosing a cloud service that gives the customers a low cost without compromising on the performance and scale. So basically, having the scalable data lakes or purposeful databases, the seamless data movement, this unified governance, and then a cost-effective solution, this is what we call a modern data architecture. This is where a lot of our customers are moving toward this, a traditional data warehousing silo model to a modern data architecture, which actually scales them along with it. Like just beginning of this session where the two examples I gave, that is what customers are doing. Like when suddenly something, the business changes, business need changes, they are able to handle that. They are able to handle that changes in the business suddenly, because they moved from traditional data models, traditional data warehousing structure to a modern data architecture. Now let's see what exactly is how the modern data architecture looks in AWS. Okay, and then as we can see, it all starts with our Amazon S3. Okay, basically customers are building data lakes on Amazon S3. One of the most popular choice for building the data lakes is Amazon S3. We'll talk about why Amazon S3 is most popular choice, what gives you the what makes S3 so special to have a data lake in the coming slides. So in addition to data lake, again, customers are also using the combination of our purposeful databases like Amazon Aurora. If you want to build a relational data, database kind of system where you want to maintain tight relationships, integrity constraints, where you want to join the data from multiple tables, you want to have all ACID compliance required for a data store. Customers are using something like Amazon Aurora. Or we want to scale infinitely, we want to have a heavy write workloads, and you also want to scale without compromising on performance, and then also want to handle the data. We have Amazon DynamoDB, which is our NoSQL database, and we also have an Amazon OpenSearch service, which previously we used to call Amazon Elasticsearch, which we call now as Amazon OpenSearch service. And other thing is that I told, the third point, like the first is scalable data lakes. We are having S3. The second, purposeful database service, as I told, we are having Amazon Aurora, DynamoDB, or Redshift, or a timestream database, or a graph database, or it could be like a QLDB, like for which is used for a blockchain. We are having this purposeful databases. But what about the seamless data movement, like which is required? This is where we have something called AWS Glue, our serverless data integration service. Using Glue, you will be able to move the data seamlessly between the services, which you can crawl the data across these services, across the data stores. You can actually do the ETL transformations on this data, or when the data is coming, you want to do some data preparation, you want to do some data cleansing, you want to do some basic data transformation. You can use something like Glue Data Brew, which will help you do that. So we are having the Glue service, which is helping us to do all this data movement. And then the next aspect we talk about is unified governance. This is where AWS Lake Formation is helping us. So AWS Lake Formation is a service to manage the security and governance of all the data, regardless of where it sits. For example, you might be having a data lake, and this you are having DynamoDB, you are having Aurora, you are having a SageMaker, Redshift, EMR. Instead of having the governance at each of these places, Lake Formation helps you to centralize all the security and governance in one place. Now you can actually configure these databases in Lake Formation. Just to give an example, I can say in Lake Formation, for this employee table in Aurora, the AI ML engineer can only see the employee age and maybe his date of birth, okay? And maybe somebody in the HR who is trying to get a dashboard of it, they can see all the details of employee. Maybe somebody, employee alone, he can see only his information, like his or her information. So by basically, you want to have this kind of governance, that's where the Lake Formation helps. So instead of having you set up these rules, typically that's what a lot of times we used to do in the past. You're having 5-6 databases, 10 databases, you actually do all these integrity constraints or all this checks and balances either in the application code or you do in the database level. Instead, now you actually use Lake Formation to centralize all these things so that it will be easy to govern. And last but not least, in all of these services, we have invested heavily in offering the best price and the performance. Like you have all the tools for us to make sure that you build a cost-effective solution without compromising on the performance and scale. So having said this, so now let's get to the data lake. Just to recap what we said just now, we talked about the evolution of the data architecture in AWS and what are the important things, what are the basic tenets of a modern data architecture and how AWS supports. Now we talk about the central piece in this data architecture, which is the scalable data lakes, right? So let's talk about what is a data lake, okay, and why I should use database. How does data lake helps me to meet the challenges what we have, like how it can actually help me to scale and then also meet the changing business scenarios, business environment. So basically, if you want to define a data lake is a central repository both for a structured and unstructured data. So that's different between a data warehouse. And then maybe throughout the session, you always have this question like, how different is data lake from a data warehouse, right? Because in data warehouse also, we make a centralized repository. I bring the data from different sources. It's just not both structured and unstructured data, but we'll talk about more in the coming slides. Then maybe end of it, you'll understand clearly like how the data lakes and data warehouse are different. Either when to use data lakes, when to use data warehouse, how these data warehouse and data lakes are related. We'll talk more about the coming slides, but basically what is happening is data lake is helping, as we told, instead of having the data in the multiple silos, it is basically a centralized repository for both a structured and unstructured data. That means you could have the relational data which is in properly in some tables with columns with all the constraints, you can bring them. And then unstructured data, like it could be semi-structured, unstructured, both. Like you could have some JSON, YAML, Parquet files, or you could have some free-form text files coming, or it could be something like your, some tweets, some messages from your social media also, right? Or it could be some kind of a messaging app. Your data could be coming from multiple places, both structured and unstructured data. So data lake is a place to store these both structured and unstructured data. So the second thing, other important thing about data lakes is you store as is, right? Typically, if you want to store the data into a relational database or data warehousing, you need to take the data, transform it, convert into the form where you can store it into the corresponding table, right? As a row, it has to meet all that requirements of the data type, the length, the constraints, and everything. You will not be able to store as is. That's a challenge we are having today. Like some underlying data changes, you need to change whole data structure, the code, application, whole stuff has to change. And second thing is, we are able to store this in open source format. You can store in a as simple as a text file, or it could be a CSV file, it could be a JSON file, it could be a Parquet file. You can store this in a open source format. And as soon as this data is stored, we can store it as is format, we can store in the open source file format. And as soon as the data is stored, the data is available for analytics. That means you can immediately can start querying the data. Just to give an example, say you are getting a streaming data, some kind of a clickstream data. Every time somebody clicks on a particular page, you want to capture the clicks of that user clicks. So basically, using some Kinesis stream, the data is coming to Kinesis every time user clicks. Then from there, it is going to an S3 where we store the data as a JSON. And as soon as the data is stored in the JSON, you are able to query the data using Athena. Like I can immediately in the real time, I can query the data, like how many users are clicking on this particular link at this point of time, what links users are clicking, and where they're having a lot of challenges, right? Basically, this is what when I mean storing the data in as is format, in open source format, and then available for a direct analytics. So another important thing, what we saw, right? Basically, if you see what happened, basically before the Hadoop world, before Hadoop became a widely adopted, the dominant, like most popular paradigm for analytics used to the data warehouse, right? So, but not that these data warehouses are not good. They are extremely good at querying a structured data, okay? But they are never designed to handle the variety of the big data types that Hadoop was able to build and analyze. So, and again, to deal with this large data sets, in case of the old world traditional data warehouse, you would have to properly cut them into multiple segments, and then you need to apply ETL transformations on them, feed them data warehouse on a time basis with a lot of complex ETL processing. And then this is also time consuming. It's not like where you can do this kind of analytics in near real time. So basically, the overhead of managing this ETLs, or the complexity of the ETL, the technology, the tools, the skills required to build this ETL tools before we can store the data in data warehouse, basically often not encouraging the organizations to quickly adopt, to quickly bring in new types of data, bring in new types of data formats, which could help them to analyze them, which could give them some kind of a business advantage, like a competitive advantage. So this is where the data lake is solving the challenge, which was there in traditional data warehouse. Let's get into some of the challenges what how data lake address, right? We know that data lake is a centralized source for the data repository. We can store the data as is, and then we can store in the open source format available for analytics immediately. But how does basically this helping to address the challenges what we had in traditional models? The first thing is the data is distributed in many locations, right? Typically, as I told in the beginning slides, you might have an ERP database, you might have a CRM database, you might have an orders database, you might have an HR database. The data is distributed in many locations, and a lot of times I have experience where customers will use a different data stores for each one of them. Like there could be a CRM application which depend on an Oracle. There could be an order management application which depend on a SQL server. There could be another HR application which is using PeopleSoft, or if somebody is using a SAP, either ERP. Each data store is different. The data formats are different. The data is distributed. So there is no single source of truth. If somebody asks me for say a retail company, can you tell me about what details about this order? ERP might be storing about the orders, and then in order management system is storing about this order information, but it doesn't have information about the customer who actually placed the order, right? For example, take a simple order management system. I am having an order. An order is having a customer, an item, the address, the payment information. The e-commerce system knows only the order. Maybe it is having some basic information about this customer, but do I want to know like what type of customer he is, like what segment this customer belongs, what is the purchasing patterns of this customer? Then that is not there in the e-commerce system. That is there in the a CRM system. CRM knows only about the customer, and maybe I want to know like what are the different payment methods used by this customer, and what is is it like is there any changes in the spending patterns? That is not there in the CRM. That will be there in some financial applications, a financial system. Or I want to know this customer is placing order for this order is having these items. How is inventory of these items across my warehouses, across my stores? That information will be in somewhere in some ERP system, right? There is no single place. And somebody, I want to build an analytics dashboard combining all this information to give a near real time that customers who are in this segment, who are of this type, are actually placing orders of this type, and then we have the inventory of these items is less in this area. That means when somebody is having this kind of 360 view, they'll be able to take a better decision. That means they know that there are some warehouses where I have more demand for this product from this customer segment, and I don't have enough inventory there. That's where it helps here, where you store and analyze all your data from all sources in one centralized location. The second thing is, how can I collect data quickly from various sources and stores efficiently? Again, the data stores are different. The S3 being the centralized repository, one thing is that we can quickly ingest the data. That means I don't have to worry about the schema. Like you don't have to predefine the schema. Like typically, if you want to store in a relational data, the data warehouse, you need to have a table with the columns, the data types, everything, right? It has to meet all the requirements before I can ingest the data. That requirement is not there. That means today I'm having 10 attributes, 10 fields in my order data or my customer data. Tomorrow I'm having some 12th one, 11th one. All I can do is I can just add it and store it as it is. I don't have to change any of my data structure or data formats to ingest that. That means time it takes to ingest the data has been reduced. And third important thing is the scaling of how can I scale up with the volume of data being generated, right? So this is a challenge what we have the databases. You cannot scale the storage and compute separately. Either you scale all of them together, you scale down all of them together. That's what advantage of having a data lake. If you're having S3 as your storage and you're having compute is different. It could be Athena, it could be even if you're using some custom built applications to query this data lake, you will be able to scale S3 and just compute separately. You don't have to constrain when the data volumes are growing. You don't have to scale everything together. You scale only what is growing more, and you can also do an on-demand scaling, or you have multiple scaling models. You can leverage all of that. Yeah, the next challenge is we are having multiple analytics and processing frameworks. They use the same example I told you. We use the same data. So basically, the advantage data lake is having is it enables analysis by applying schema on read, not on write. It's one of the most important concept of data lake. What we had in traditional database, schema on write. That's what I was telling just now, like where you need to plan your data, your schema in advance before you can write. But data lake is more of a schema and read. So as the same example I told, if you're having a 11th attribute added to a customer data, something like you are adding, customer demography, or maybe just say, suddenly we are having a requirement to track customer vaccination status, like whether they're actually took a vaccine or not. There's a requirement for every employee to have vaccine, something like that. So suddenly what happens is you are having a new type of data you're capturing, right? With the data lake, with schema on write, all you can do is you can just send the data, store it in S3, you go to Athena, and you'll be able to query the data immediately. That means you are not doing any changes anywhere in the your whole end-to-end stack to add a new attribute to the data. That's a major difference between building analytics applications in the past to now. In the past, if you want to do the same thing, you end up changing the code, you end up changing your database, you're changing your ingestion mechanism. Everything has starting from the ingestion to the consumption. Every layer will undergo a change, and then you need to deploy these applications, and you need to take it through all kind of testing and everything. That has changed now. You can add a new attributes, you're able to query immediately without changing any of your whole stack. So this is a proof that the number of data lake, more number of data lakes, runs on AWS anywhere else. This is some of customers who actually leverages S3 as their data lake. Okay, now let's talk about what is building data lakes on AWS. Let's quickly walk through one scenario. The first thing is you set up a storage, right? Basically, what is the storage in this case is S3. Typically, that's what you do. Like data and maybe Kinesis Firehouse to store the data into S3. Or it could be large volumes of data. You might want to use something like our Snowball family services to move this large amount of data into S3. So you are having the multiple options to move the data. So once the data lands into the S3, you need to once the data lands into S3, you need to cleanse, prepare, and then catalog the data. For example, once you are getting some 10 attributes, you want to make sure that you don't require all the data, you require only part of the data. You want to remove some columns, and when the data comes, you want to actually use cleanse the data, like remove some special characters, or maybe convert. You are getting temperature data in centigrade, you want to convert into Fahrenheit, or you want to transform some other transformation. It could be anything. Basically, you can use something like data views service, which is a visual tool which is having more than 250 different type of transformations built in. So without writing a single piece of code, you will be able to transform the data, do all the data preparation. Or if you're having very custom kind of a code you want to build, you can use for glue ETL also. And then once the data is prepared, once the data is available, the next big thing is cataloging the data. Basically, data catalog tells where what is the data, what are the fields available in this particular data, what are the data fields and their data types and everything. That's where we have a glue data catalog. So we can configure a glue crawlers. That means as soon as the data lands into the S3 bucket, once it is cleansed and prepared, the glue crawlers can pick up the data, crawl the data, and prepare a data catalog. So once a data catalog is built, then basically you know that what type of data which is there, like it's a kind of a menu card for your data. And the next important thing, once you have done all these things, now data is cataloged, but the most important thing is that we need to configure security and compliance. This is where the lake formation comes into picture, where we can use the lake formation to configure security and compliance. So once I have the governance, the security and all the policies are defined, next thing is that making the data available for analytics. That means you can use data to build a dashboard, you can build some APIs, or you can build some apps, you can do all that stuff once the data is available for analytics. So these are the typical steps when you're building the data. So one of the most important, all the steps is that you need to set up a storage, moving, cleansing, preparing, data cataloging, the governance, and then the consumption, that is, which is making the data available for analytics. Yeah, I think we talked about this a little bit in the past, in the previous slides, where what is the data lake infrastructure, what we are having. Again, we are having S3 is the central our data lake, and then Athena for you to query the data lake, and then you are having EMR to process the data. That means the data is in data lake, but you want to process it before it can be consumed, to be EMR. And we are having Redshift or data warehousing solution, where you don't want to store, there could be some amount of data which is mostly a relational data which is having tight relationship. You want to run a query with a lot of joins, then we can use Redshift, which is a petabyte kind of a scalable data. And then we are having Kinesis to ingest the data into the data lake, streaming data. On top of it, we are having SageMaker, which is our AI/ML service to train and deploy the model. And then we are having a Snow family, Snowball, Snowmobile kind of services to move the data to the data lake, any large data to the data lake. So, and then why S3 is more popular for data lake, why a lot of customers use S3 is that it is durable. We are having 11 nines of durability. You're not really worried about availability. It is 99.99% available all the time. You can do multiple uploads. It is one of the, you can have the get operations. It is very easy to use. All you need is some kind, you can use it like a simple REST APIs. You can using SDKs. Even you can configure lifecycle policies that once the data reaches some stage, I want to archive this. And there is no limit on the scale. It can scale depending upon your need. And then it is having a built-in integration with pretty much most of the AWS services, like whether you want to use EMR, DynamoDB, SageMaker, Redshift, or you want to use some Lambda for processing. All of them are integrated with with the S3. So basically, that makes S3 one of the most popular choice for data lake. And another important thing is that AWS lake formation. Again, AWS lake formation also helps to build and secure the data in the cloud. We talk S3 is for helping you to store the data, and then you can you can scale storage, compute separately, schema, and write everything. But with the lake formation, you can actually simply point a data lake to data this lake formation, and then it can automatically register. It provides you a blueprints for automatic registering the data lake. Once you register data to the lake formation, all the governance aspects of that data lake is handled by lake formation. So to see like how it handles, you have on the left hand side different data sources. It could be S3, it could be relational database, NoSQL databases. There is a predefined blueprints which you can use, or you can use if you know the location already, you can register location lake formation. Once you register location, it is having the crawlers to crawl the data, and then we can use ETL for data preparation, and then the data catalog to catalog the data, and then all the access control security settings. That means anyone, and then you can tell who can access this data. You can define all the IAM roles, users. So anyone trying to access this data through Athena or to Redshift or EMR, the same IAM user, same role can access the same data from multiple services. Depending upon the irrespective service is accessing, the governance, everything is in one place. That means I'm a user, sometimes I use Athena to access, sometimes I'll use an application to access the data. I don't have to configure the governance in two places, because both of them are actually referring for the governance and access control from the lake formation. Yeah, this is what an integrated data lake means, where if you see for the real-time processing, you are having an open search service, you are having Kinesis data analytics, which is once the service where you can run the analytics on real time. That means, say for example, you're getting the clickstream data or payment data or IoT data, you want to run some analytics in real time on that, you can use Kinesis analytics, you can use predictive AI predictive analytics, and then for visualization, you can use QuickSight, or you can also use our partner BI tools like Tableau or MicroStrategy or Kibana, which is built in with Elasticsearch service. So the next, we'll quickly we talked about what is a data lake, benefit data lake, how do we build a data lake. Let's also talk about what we can do with data lake. How do we consume? If the data in data lake S3, one thing is you can query directly with Amazon Athena, like write a SQL query, which will give you the results like this, or you can actually analyze with Hadoop on Amazon EMR, Hadoop, where you are having the data, but you want to write some complex code to do the transformations or analyze, or you want to do some kind of a map reduce functions. You can actually build using the using Hadoop with on Amazon EMR. Or you want to build a dashboard, you can use QuickSight to build a dashboard. Again, all of them are referring to central data lake. Or if you want to build a data catalog, AWS Glue, this is what a data catalog looks like. It tells you like what is the database type, the location, what are the different tables in this, and data type of the tables. And also you can train an ML model with Amazon SageMaker. The data is in data lake. All you can do is point your SageMaker to the data lake, where you can use that to train the models. Train the models or execute them, test them, or even deploy them. And also apart from that, you can store the data in downstream systems. You can move the data from data lake to Redshift. You can move to Aurora or DynamoDB or to Elasticsearch, which is now called OpenSearch service, or to SageMaker. So basically, one of the reasons, typically, quickly I'll add one point, like why I try to move downstream services. There could be some cases where you are having a lot of historical data, like 10 years of data, which is huge. You don't want to store all of them in Redshift, which would be mostly not a kind of expensive. So you want to store only last 1 or 2 years of data into Redshift, and maybe another all the historical data into S3. But at some point of time, for some analysis, for some trend analysis, you equate the data from both the places. Then you could actually use something like Redshift Spectrum to join the data from S3 and from Redshift to build this analysis. So this is intro about the data lakes, where we talked about the data lakes, the purpose, the advantages, how we can consume the data. In the coming sessions, we'll talk more about how do we hydrate this data lake, how do we consume this data lake. Pretty much whatever we talked about today in this session, we'll expand on that in the coming slides, in the coming sessions. So I'll hand it over to Lance for the next session.
Cool. Thanks, Gandhi. Can everybody still hear me okay?
We can.
Nice, thanks. I changed my audio up, so just getting my settings right. Okay, so as Gandhi had mentioned, I'll be doing the next slide covering how we hydrate the data lake. So let's get into it. Kind of funny play on words, this new constructs around the data lake, and kind of how we have this breaking out of the traditional data marts and going into more of a non-relational model where data can continually change and evolve over time, and our data systems scale with it. With the new terminology, of course, now that we have a data lake, we need to hydrate it, fill it with data or water. Ha ha ha. But as Gandhi had mentioned, the backbone of these data lakes on AWS really is S3, right? So S3 is kind of the core storage component, and the AWS platform services around it offer a whole array of functionality and different ways to interface and interact with the data, ranging from like the networking architecture, and establishing connectivity between sites, things like transferring data, time series databases, different systems which can parse the data and set up alerts on it. Being able to filter and like kind of real-time analyze the data. There's all different ways to slice and dice these type of workloads on AWS. And the great thing about all of these is that they're managed services from AWS, and that they integrate very nicely with each other. The policies are multifaceted and can be used to overlay on top of each other so that you can have a very secure cloud deployment. I'm sorry, my screen is paused. There we go. Can everybody see the depiction of the session focus working in the data lake? My share was paused.
We can.
Awesome. So this is kind of, as I was going through these interfaces and the different services and tools that I was describing, this is the image I was referencing. So all these different components on AWS, which are all pick and choose as you need and pay as you go, and all sorts of different pricing models and how they can be interwoven for the platform that you're trying to build. And of course, there's not really one right way to do these things. A lot of times there are common patterns or recommended patterns, but the implementation typically ends up looking unique for each customer. It really depends on the business and the applications involved and the team and the type of tools that they want to use. But the point here is that AWS has a broad range of services which can address all of our customers' data needs. And Mission, as a consulting partner, we're poised to provide engineering resources and talent to be able to help organizations do this. And that is from both like a consulting standpoint and as well as implementation and providing like data engineers to actually go build this stuff in AWS and not just talk about it. So before I get into some of the content in this deck and move on to the labs, I'd just like to kind of reiterate that there's several of us SAs on the line here, and we want to help in any way that we can. So please throw your questions into the GoToWebinar little control panel. Ask us anything that's on your mind. We're happy to get into some of the specific asks you may have, or if it's kind of questions around a larger project effort, we'd love to hear them from kind of a consulting standpoint. So let us know what's on your mind. And with that, I'm going to get into it. So this is a breakdown of some of the data sources that we're commonly seeing being migrated and operated on AWS. The most common is databases. Customers have applications in all sorts of frameworks, in all sorts of database engines, some relational, some non-relational. These are typically open source, sometimes more the paid offerings like Oracle, for example. But this is the most common kind of data source that we see in terms of these these data analytics workloads being deployed onto AWS. Kind of following up from there, streams. So this is workloads that rely on technologies like Kafka, for example, or an IoT workload that maybe is making use of something like MQTT and having this broker. So streams is another common data input. It's a bit different from a database, and it's not like a traditional system where you can export a data set. It's just kind of an always on sort of thing. And the mechanisms that we use to ingest streams will be a little bit different from how we'll ingest databases. So these different types of data sources dictate the type of tools that we use to migrate or to deploy, and how we go about doing any of this sort of migration or deployment work. Logs is kind of a mixture of streams and files, I would say, but logs can be written or streamed to a file on a file system, or can even just be emitted directly from an application, right? So if I'm working at an organization and we have a series of like microservices Java applications, for example, I may have instrumentation within that Java code which is emitting logs, which can be ingested and stored in a central place and parsed and alerted upon. There's lots of third-party tools like Sentry, for example, where you can build those things in, or things like New Relic APM, for example. And kind of the final one referenced there is files. So that's really just files in a file system, data that's sitting on a disk somewhere. Typically, some application or some service would need to interact with a file system and read files off a disk. And of course, the different advantages to using a disk-based solution, and then disadvantages, and then likewise with any sort of object file solution. Different pros and cons, and the idea is that the AWS platform gives you enough flexibility to pick and choose services as your needs evolve. So because databases are the most common data source that we see, we'll start off talking through what that process looks like and explaining in a bit more depth. This content is a bit tactical, a bit more technical in nature. So we're going to be getting into some of the specifics on methodology and tools and how to actually go about this sort of move. So if you kind of notice this depiction here where it shows databases in S3, and your initial thought was like, well, if you have familiarity with using S3, your initial thought might be, well, how does that work, right? S3 is not really like something you mount. You're not going to serve a database from an S3 bucket, and that's really not the point. We are big on this methodology of using some sort of change data capture to basically be able to capture what has happened within that transactional or relational database and maintain a record of all the changes over time. And there's a few different methodologies at play in how we go about that. There's a push model where your source system has some trigger and is sending updated data sets to another system, or it can be more pull based, right? Where a system is kind of pulling it in or reaching out to the source system from time to time to pull the latest data sets. The methodology you choose is largely defined by the type of system that you need to have in terms of real-time analytics. The closer you are to real-time and the faster that data set needs to be populated, you'd be looking at more of a push system. You want that thing to be getting updates as soon as the data comes in and not necessarily waiting for some batch to occur. There's a few ways to go about this on AWS, and I'm going to walk through a couple of them. A lot of the approaches require or depend largely upon an AWS service called AWS Lambda. So this is a serverless computation service, and it basically allows operators to define workflows or logic in code. And this can be any sort of common programming language that your organization, your developers or engineers are familiar with. I come from more of a programming background with Python. I'm a Python developer. So I write a lot of Python-based Lambda functions, which do this sort of data manipulation, reading from a source system, capturing raw data, storing raw data into S3, and then having additional functionality to parse and transform and load that data into other places. So this can get very complex depending on the organization's data needs, and has a lot of room to fork off into other components. Because even in this simple depiction, we're just doing a simple, grabbing CDC for this one record that had been updated. But in a production deployment or something more robust, we'd likely be looking at more of a forked path where as raw data is coming in, it's being split into several places. In some places, we're doing window-based analytics, and other places we're just storing raw data, and in other places we're doing more ETL, and we have more of a pipeline involved. So this is something where this is the general trajectory, or this is the general tooling of what this type of system would look like, but this has the potential to become very complex depending on your data needs. But the other kind of core services there, aside from Lambda as the compute and the logic, and S3 as the storage, is Kinesis Firehose. So there's a couple components to Kinesis which makes it very valuable for this type of data ingestion and analytics workloads. We'll go more into the components of Kinesis, but for now, just know that anytime we're building solutions which require heavy amounts of ingest, you should be thinking Kinesis. What's great about this type of solution is that all these AWS services are not only managed, but they all link into each other very nicely. So as we see when we go through the labs, all these services are largely plug and play. You can show up with a lot of predefined templates in a lot of cases and customize for your unique use case. And there's a lot of starting points that makes it easy for customers to just get started and launch some CloudFormation templates, for example, and have a reference architecture that they can start throwing data into. We actually plan to do that in our lab once I get through some of this slide content. This kind of second depiction here is more of a follow-up from this kind of initial thing. What this change data capture allows us to do is basically store and archive every version of our database. Every time it changes, we're basically storing the new info, but in another place. So we kind of have a copy of our previous data set, and we can really look and analyze how the data is changing over time and not just be a snapshot of what it is now. So this is very useful for analytics purposes, and for companies who are big on evaluating and analyzing their data sets, this is a really important concept to have in place. So this is walking through some of the triggers or how you would actually go about doing that. The slide's not a whole lot different, but it is trying to showcase some actual data. What data might look like sitting in a database and how that would need to be how to set up the triggers so that when something changes on the source side, it's getting routed through this system. So I wanted to kind of skip forward to this kind of V2 slide to show you a real example of what that might look like. So in this scenario, this customer is using MySQL in Amazon's relational database service, RDS. So they got a MySQL database instance running, and within that database environment, right, an administrator was able to create a stored procedure that would invoke a Lambda function asynchronously. In this case, it's CDC, change data capture from Aurora to Kinesis. And then also within the database session, they create a trigger, after insert on sales. So in this sales table, there is now a trigger in place. So anytime there's an insert called and some data is inserted to that table, this Lambda function is going to get triggered. And this is essentially a push mechanism. So the database is going to be invoking the Lambda function, which pulls in the change data, which pushes that to S3. kind of another variation, but instead of a relational MySQL database, we're looking at Amazon's a non-relational database product they have, DynamoDB. So this is kind of API-based non-relational database service, very high performance, but because it's a managed service and unique to AWS, it has kind of snap-in integrations where you can enable a stream on that DynamoDB table or set of tables. And very similarly, it'd be able to invoke Lambda functions and pipe results through Firehose and put them into some other data source like S3. And of course, kind of the last known method there is using the built-in database engine to achieve this. This is another option, another avenue that database administrators or operators have available to them. All of the major open source and paid database engines will have some sort of mechanism where you can store transaction logs to be able to replay back. This type of system is feasible, but usually it's something you'd have to spend more internal engineering to create, because you're going to want to implement the workflows behind, replaying transaction logs or capturing the data changes from them and mapping that into your S3 and your storage environment. But it's an option. So before I go here, let me just get my phone set up so I got my time check in place. So we've been about 20 minutes in, got about 25 minutes left. I want to go for a few more minutes on this content, and then I would like to get to the lab. There's a few things in life where I don't pass up the opportunity. If somebody offers me money, I will graciously accept. And if somebody offers me an AWS account for a lab environment, I will also graciously accept. So I would urge you all to do the same. Everyone should have received links to something called Event Engine, which should spin up a temporary AWS account that you can go through and do these lab walkthroughs. I would highly encourage everyone to run through some of these labs. They're pretty plug and play and easy to get some infrastructure deployed on AWS and playing around with some of these data and analytics services. Just give me one sec. Okay. Oops. Alrighty, moving on. So I'm going to briefly talk about a couple of the migration tools that we commonly use and recommend for any sort of migration. So the first one is database migration service. So we're going to cover this into more detail, but essentially it's a managed services which allows administrators to very easily and quickly define some replication jobs for source databases and to be able to replicate them to AWS. And that can end up in another relational database, a data warehouse, or even S3. So there's ways to kind of use DMS to get a lot of your source data systems migrated into AWS in a ongoing fashion, where you're kind of continuously replicating data, and it's good to get set up, in advance to any sort of migration. You can kind of just let that run. The next tool that I want to bring up is the schema conversion tool. So this is a open source tool which essentially will evaluate your schemas and produce recommendations and even generate some SQL data. So it's a useful tool for administrators to assess and better understand their database, really the specifics of the configurations and the schemas, and it helps ensure that if there is any sort of data engineering that needs to go into some sort of replication job, SCT will help flush those out. Very useful for changing systems as well. We see a lot of customers utilizing SCT to switch from Oracle to Postgres, for example. It helps with going through that process of translating the different queries for the different database engines and converting to other open source products essentially. So if you're considering a cloud migration and you have a database, you're probably going to be using one of these tools. So I should have saved my little spiel for this slide instead. But this is kind of the use cases of these tools here, right? So modernizing, migrating, or replicating. The SCT will help modernize. It's probably the most common use case is helping customers get off of some paid database engine like Oracle and going to something more open source. It's much more cost effective to use an open source engine and much more scalable. These tools help with migrating, helping administrators and developers make adjustments to their system to make better use of the open source engines and get them on that kind of open free model. Same thing for data warehousing, right? So that these tools are effective for modernizing data warehouses as well. They really give administrators the ability to assess their schemas and make adjustments to improve efficiency and performance. And of course, kind of the traditional use case there is migrating, just moving data from point A to point B. DMS is great because you can define some jobs, you plug in some source information, like here's the host name or IP, here's the secrets to authenticate to the database. Normally you'd have to punch in some credentials and access for the replication job on AWS, but you basically get a managed compute instance whose job is to just move data from A to B, and you can give it certain criteria. You can move specific rows or specific columns in specific tables. You can be very granular with how you move the data from A to B, and that's really kind of where a lot of the power of this service comes from, because you can kind of set it up and let it run, and if you need to make adjustments, you can make those on the fly and have this replication instance just kind of keep doing its thing. And last kind of item there is around replicate. So one of the most powerful features of the managed databases, in my opinion, is the ability to scale them up. Especially services like Aurora. If for anyone not familiar, Aurora is Amazon's kind of custom implementation of, there's a flavor for MySQL and a flavor for Postgres. It's not true MySQL and not true Postgres. It's like Amazon's implementation of the engines, but they're drop-in. But they have a lot of flexibility in how that model works and how it's like a cluster that you can spin up many instances. It's really easy to just spin up read replicas. You can run analytics on read replicas, spin them down when you're done. And because it's all cloud-based, you can orchestrate all these processes. So you're only paying for replicas when you need to be running reporting. You have the opportunity to automate a lot of this infrastructure type of workflow. Sorry, just checking for questions. Alrighty, so talking more about DMS, so it's pretty common for us to deploy DMS in some fashion where, customers will have many source databases, and while working with them, we get a better sense of what data they're keeping, what data can be pruned or can go away, and helping customers come up with essentially the plan. How are we going to get this data from A to B? What sort of changes need to happen to the data? Are we modernizing and switching to some other engine, or are we kind of doing a straight lift and shift and just moving data from A to B? And it'll mostly retain its shape and form. But the deployment of DMS is typically pretty simple. It can range, you can have more machines as needed to replicate additional systems and data, but the intention is a fully managed, scalable service so that no matter how many source systems you have in scope for deployment, you can spin up any number of DMS replication instances, and those will be online and replicating data into your systems on AWS. So one of the targets that DMS has, you don't necessarily have to ingest data from a relational system and then send it to another relational system. You can use S3 as a target, right? So you can essentially import or kind of replicate data from your database and define a schema on the other end and have it output into an S3 bucket. So this is a really powerful functionality because it's kind of a straight shot to get data over into S3 into your data lake. So this is how a lot of organizations get started. Just implementing DMS on one of their simple databases on-prem or in their current environment and establishing a DMS job and bringing over that data and just beginning to have some data set there. And the great thing about these systems is that it allows you to be very flexible. If the data set that's being captured in your initial run through isn't sufficient, you just make an adjustment and the replication instance gets updated, it starts pulling its new data set, and you see the new data format hitting in the S3 bucket. All right. So I'm not going to have enough time to cover the entire deck. So I'm going to jump around briefly just to touch a couple of the slides I wanted to get to because I still have some of the lab content that I wanted to show you all. But let me just talk about this other data source around files. This one's very kind of important. A lot of customers have big file systems and just kind of object-based workloads on-prem that need to be migrated in. And similarly to the database source systems, there's a lot of different options for transferring files in and out of AWS. So I'm going to kind of just briefly touch on some of the services. In summary, I would say there's different methodologies or ways that you can approach this as well. The most common one that we see is typically Snowball. Customers will use this kind of shipped hardware device, that's sent to their, I don't know if I have a slide for it. I don't have a slide for that, that's all right. Snowball is essentially an appliance that gets shipped to your data center or your office or wherever you have a large amount of your infrastructure. And you essentially receive this device, you plug it in your network, you upload a bunch of your data in bulk, and you send it back to an Amazon facility, and they will export that data into an S3 bucket that you create and reference when you create a Snowball job. So we typically see customers use the Snowball method to get an initial data set seeded and then follow up with some other service like data sync, for example, which will essentially do continuous file-based replication. SMB file shares, CIFS file shares, Samba file shares. It'll read these different file share technologies and sync those with a destination source. And there's even a few targets for that as well. Regarding like networking, one of the kind of biggest recommendations that we have is to set up a direct connect. So direct connect is a fiber line from your data center, your on-premises environment. If the data center provider supports direct connect and you're going to maintain some sort of hybrid cloud infrastructure, you're going to want a direct connect. That fiber line is very important to have just to ensure that you have a consistent link to your AWS VPC. Data sync I touched on, that's essentially an agent that's going to run in your on-premises environment. So it's typically deployed as like a virtual machine. There's an app image, I think you're like a VMDK or something that you can just plug into VMware or the competing Microsoft one that I've just drawn a blank on right now. But you can deploy this agent into your on-premises environment, and it's going to replicate continuously to some source system, or I'm sorry, to some target system like S3 or EFS, right? So that's Amazon's network file system technology. Okay, I'm going to gloss ahead a little bit. Streams are big. We're seeing a lot more customers running Kafka-based workloads and things like MQTT. These sort of software components where there's just always kind of some streaming data that needs to be ingested. For these type of workloads, we typically will recommend Kinesis or using an Amazon managed Kafka, for example. It kind of depends on the customer's system. If it's already kind of programmed and it's already working with Kafka, we'll implement it around MSK, which is Amazon's Kafka service. Otherwise, if the system is still kind of being built and defined, we'll typically recommend customers start with Kinesis because it's all API driven. Developers and engineers can implement workflows and implement pipelines just within their application code and just use the SDK to interact with Kinesis streams or Firehose or analytics. There's really a whole tool chain around Kinesis and a lot of just kind of snap-in integrations that are available out of the box. So different streaming technologies, different kind of storage and analytics technologies can come into play here. But Kinesis is highly recommended for large-scale data processing workloads. And if you need a heavy amount of ingest, you're likely going to be looking at Kinesis unless you've already spec'd the system off of Kafka. This is kind of a sample architecture. This is actually what we're going to be doing in the lab, which I'm about to start right now. So just a few different examples of how you can architect a solution on AWS, given all these piecemeal components, and how you kind of assemble those things to build a sort of holistic solution. And it's really just a combination of the services that we've talked about so far. S3 is kind of the core storage platform, Lambda for your compute and analytics, logic, manipulating data, doing a lot of the ETL work. Kinesis for the ingestion. There's a few different components to Kinesis. It can be a little bit confusing if you're not used to it. Some Kinesis parts are just for moving data from A to B. If you see data Firehose there, the arrows are pointing to S3. Firehose is just taking data from A to B, and then other components like data stream and data analytics allow you to inject some additional logic on top of the streams, right? So you can write Lambda functions to parse the stream real time, and we'll typically see customers using things like Dynamo as a temporary scratch pad to store state, and Lambdas can kind of just be continuously being invoked in the background and parsing the data set and updating a Dynamo system. Last thing on logs, there's a couple different log methodologies. CloudWatch is Amazon's de facto monitoring service, but for customers who are sending logs to disk and need the ability to ship those file system based logs into their data lake, there is an agent that you can install for all the common Linux and Windows operating systems to be able to just stream those log files real time with that agent and then ship it to S3. And in the end, you have a cloud-based platform that can do all of the ingestion, all of the extract, transform, and load operations, all of the resilient, durable storage, whether that be object-based or file system-based. You have all the security built in so that you can define very strict and stringent policies on not only the data sets and the tools involved, but the services that are being deployed. There's a lot of granularity that can be built with this type of system. It's a very powerful platform for doing these data-based operations. And a partner like Mission is poised to help customers design and implement a system like this. I'm going to switch gears and go into the lab.
Hello, everyone. It's Melissa from the Mission Marketing team. Thank you all for joining. Lance, I just wanted to call out, we do have a question. So take a look at that when you get a moment. And for those of you that do not have your access to get into that lab environment, just feel free to message me directly. I'll make sure you're all set up.
Thank you. Sorry, I'm just getting my browser tabs up and going. Good enough. Okay. So we're going to be going through this data engineering lab. I'm going to post the link here. So the lab is pretty dense. It's a very good introduction to a lot of these AWS analytics components. Pretty much everything that we just walked through, we're going to be deploying an infrastructure that looks largely similar to one of those final slides I was showing in with the deck, with the content. But the kind of first component to this is going through a pre-lab, which is if as soon as you all get access to your AWS account, I would recommend going through there. If you recall back from the previous slides, this architecture was depicted there, and we're going to set that up. And I'm just going to do this on my screen, and you can follow along. But I would urge you all to do this on your own as well. I'm sorry, excuse me 1 second. I have to go let the dogs in. I'll be right back. Pardon me. All right, sorry about that. All righty, so what this lab is walking through is basically deploying this infrastructure. The lab makes it pretty easy. It's starting with a component of AWS called CloudFormation. And so if you're in this lab and you're authenticated to this AWS account that we should have shared credentials with, you'll be able to essentially click this button here, deploy to AWS. And if you look at the link, it's going to take you to a service of AWS called CloudFormation, where we can basically define infrastructure, platform configurations, AWS specific stuff in some sort of like JSON or YAML template. I'm going to open it up and just kind of check it out to show you all. But this is, there's some parameters, some inputs that this CloudFormation template will make, and it's going to create, the infrastructure that was depicted in there. Oh shoot, I'm sorry. I'm only sharing my browser. Let me share my screen. I had opened the CloudFormation template to show. So just a simple little YAML file, and if you look in here, if you take a look at the link and open it up, you'll see it's making some buckets. It's making a Kinesis Firehose delivery stream. It's going to reference the bucket. It's going to make some IAM roles for security with some policies around them. So AWS manages and maintains these CloudFormation stacks for their lab environments. So it should be pretty plug and play for everybody. I'm going to go ahead and call my stack name Lance Kinesis Pre-Lab. I'm going to make my own username called Lance. My password will be a generic one. I'm going to plug in my mission email and my cell phone. You got to click the box that acknowledges that this CloudFormation stack will create IAM resources, and we will launch it. Oh, I need a fancy password. Cool. So now this should not take very long because the infrastructure involved is pretty lightweight. Sometimes you'll notice things like relational databases, for example, will take a little while to provision. It might take 30 minutes for an RDS instance to come up. Functions and buckets and SNS topics and Kinesis, Firehose, this stuff all provisions pretty rapidly. So this should not take very long to come up. I'll kind of refresh the page there, and we'll see all that infrastructure kind of being spun up in one go. Some of these things reference each other, so there's some dependencies, but CloudFormation will resolve all that. And if I click the resources tab, we'll see all this infrastructure kind of spooling up. So it looks like half of it's done already, but if I refresh again, it's probably done. Yeah, pretty close. A couple more objects coming up. For those who are not that familiar with CloudFormation, I would urge you to look into this. In my opinion, using tools like CloudFormation or Terraform or Pulumi or any kind of flavor of infrastructure as code is really, really important. In my opinion, it's kind of the bedrock of all good cloud deployments. You really need to have this infrastructure as code thing down pat because that's what allows your organization to be able to make changes faster and more efficient. And it really, you just got to get it out of an individual's head or hands. There's too many issues that can arise from human-defined change processes, and when it can be done as code, you can basically treat it like your application. You have peer review, you have pull requests, somebody can evaluate the code before it's applied, and a lot of these infrastructure tools allow you to see what will happen as a result of making that change. If you're looking at some cloud move, I would definitely spend the time to invest in evaluating infrastructure as code tools. My personal favorite is Terraform. But CloudFormation is great for stamping out quick little blueprints. As we can see, this blueprint was able to spin up pretty easily. And this is going to be the data set that we're working with for the remainder of these labs. So that, as we progress, we're going to build on top of this infrastructure and keep walking through. We're going to build a click analytics pipeline and basically just stream data, through Kinesis using a data generator, and we'll see the outputs and the results. We'll be able to parse the incoming stream of data, and send that through into Kinesis, and then build on top of it. And tomorrow we're going to kind of close it up with my favorite part, which is more on the visualizations. So making the dashboards that visualize the data and show, in some human readable interface like dollar signs and bar charts. This is the exciting stuff, the top of the iceberg that everybody likes to see. Okay. So I'm going to check my stack just one more time and just make sure that it's come up. And I'll be referencing and going back into this infrastructure and building on top of this in further labs. But if you're interested in doing the lab on your own, which I would recommend, make sure you start with this pre-lab setup and install that CloudFormation template, get that infrastructure deployed in the account, and from there you can continue on into the next phases where we're going to be creating Kinesis analytics applications and integrating this Kinesis components into the rest of our system. And later on we'll start querying the data set and analyzing it. So let me check time real quick here. Alrighty. So At this point during the event, we have a break scheduled. So, we're planning a 15-minute break from here. I went a little bit over. I should have stopped at 1:15 my time. I think 3:15 most of y'all's time. So I think we'll set maybe 15-minute break from this point. So we'll plan to see everybody back 1:35 my time, 3:35 your time. And I guess before I send everybody off on break, just kind of reminder, please do not hesitate to throw out any of your questions into the GoToMeeting question box. I'm pulling them up now and I'm ready to answer any questions you may have, especially if you're going through the lab. The content's a little dense and I'll be happy to help troubleshoot or get anybody through any of the components. Melissa, did you have anything that you wanted to include here, or do you want me just to finalize and send the break here?
I think somebody is asking, I think it's Asha, how long will the stack take? Is that right? The stack creation. How long will the stack creation take?
Yeah, I just answered in the box. I would expect 5 to 10 minutes.
Okay.
There was just kind of one resource that was taking me a little bit of time, but this should just be a couple minutes.
It sounds good, and it looks like some folks have their stuff in the creation process. So it looks like everybody's been able to log in successfully with their information. Again, if you're having trouble, just message me directly, and I can always get you a different hash.
Cool. All right, well, I'm going to take a break as well. I'm going to refill my water and coffee, and I'll be back to check on the questions box here in a minute. Hey everyone, everybody back? So next we're going to be talking through hydrating the data lake with DMS. And Gandhi will be our presenter. So let's get a hold of him and get him on.
Yeah. Thanks, Lance. Hi everyone, let me share my screen.
Excellent. Yep, we got it.
Yeah. Can you see my screen?
Yes.
Okay. Okay. Hello everyone. I think what we'll do now is I'll walk you through the ingestion of the DMS lab. Let me paste you the lab link in case you don't have it. So I'm putting the lab link in the chat window. Please click on that. So when you click on that, you will see, please go to the ingestion with the DMS. So you have got three options here. You click on the first option, which is a DMS main lab. Okay, in case you want to proceed other labs in this workshop and you don't want to do the DMS, but you still, because this lab has got dependency, unless you complete this lab, a lot of other labs down the line might not work the way they're expected. So in case you want to do other labs but want to skip, that is the very reason we are having option 2 and option 3. But now in this, since we are trying to do the data ingestion using DMS, we'll go to the option 1, which is DMS main lab. And then you have to click on the DMS migration lab. These two links are not required, but you can follow these two instructions if at all you're creating this lab in your own AWS account, not on that event engine environment we provided you just now. Since you are doing this on the event engine environment we provided, please click on the DMS migration lab. Okay, this is a lab. So what is the purpose of this lab is we are trying to migrate, ingest the data from an RDS, a relational database service, to the data lake, which is S3, using the database migration service. So basically our source is Amazon RDS, but in the real world, the source could be any database, which it could be an on-premise database, which is running in your own environment, or any other database supported by the data migration service. And then the destination is S3. So what we'll do is we have two kinds of labs in this. We do a one-time migration of all the data in this database into the S3 using the DMS service. And also we do CDC, which is change data capture. That means change data capture. That means as and when some data changes, you will be ingesting the data into the S3. So basically, I'll quickly walk you through what are the high-level steps in this lab, and then you can start doing the lab. And if you have any challenges in between, if you're facing issues, we'll be monitoring the questions in the chat window. Please feel free to post your questions and any issues that having in the chat or questions box. So the first thing you do is to set up a DMS, we require a subnet group. So that means if in the VPC, the VPC which is there in the lab, you create the subnet group. And I would encourage you to use the names which is there. You can use different names, but I would encourage you to use the names which are already there here, so it makes easier for you to refer it back in case we are having some issues or challenges, easy for us to debug that. When we deploy DMS, we deploy at least into availability zone. So you pick up the subnets, the corresponding subnets. Maybe one could be from US East to 1A, one could be 1B, one could be 1C. So you pick up at least 2 availability zones, that is 2 subnets. Once you do that, there's some basic requirements. So once you do that, you go to the DMS console and then create a replication instance. The replication instance is a one, just like you're launching a instance, kind of EC2 instance. That's where all the tasks will be running. Basically, you configure replication instance, and then you select the sign instance type, and what is the engine version, the storage you want, the VPC, multi-AZ, whether you want enable or not. So once you create that, then it will create an instance for you behind the scenes. So once instance is ready, then what you will do is you will actually configure some of the network configurations as part of instance creation, the subnet group which you created, and then the VPC security group which you created, and then if you have any KMS master key, you can use a default one or you can use the one which you have created already, but in this case you're using a default one. So once you complete this, a replication instance is completed. So you created a subnet group, and then using subnet group, using step 1 subnet group, in step 2 you have created a replication instance. Okay, that is basically an EC2 instance behind the scenes. Once you do these 2 steps, now we need to configure the source and destination. Okay, right, which we call source endpoint and then a target endpoint. So source endpoint will be the RDS in this case. That is a database from where we are trying to migrate the data, right? Target endpoint is S3. So you configure endpoint, RDS source endpoint to configure, and then you provide the server name, the port, and then for the source engine you select Postgres, and then for the access endpoint, to get the database endpoints, when you go to your event engine, you will have the database endpoints, the S3 bucket names, and then the database endpoint will be there. So you need to pick up the database endpoint which is there in your environment. And then you configure your username as master, the password type as master123 like this. The database type is sports ticket. So you configure all these things. Or you can run the pre-log command, but this is already there in your database endpoints. Once you do that, then you have the replication instance created. You have the endpoints created. Right now, you've got the replication instance, that is EC2 instance behind the scenes, and then you have got your source and target endpoints. So once you have both defined, then you create a source endpoint and then a target endpoints. Even in target also, you have got all the environment setup. In environment setup, you have to go and pick up the S3 bucket name, and then ARM for DMS lab role to access S3. You need to pick up these 2 things from the environment setup. Once the endpoints are configured as shown here, the next step will be to configure the tasks, right? The task is the one which actually copies the data from source to the target. So once, and then in the task, you've got different types of tasks, whether you want to do a full copy or CDC, but in this case, we'll do a full copy of the source data into the target. So you can also do multiple settings, like whether you want to drop the tables and target before creating the limited log mode. Log mode means like whether you want to all the large binary objects, you want to migrate them as it is, or you don't want to migrate the large objects, or you want to migrate only the objects LOBs of size 32 KB only, right? So depending upon that, it will actually, if you have any log objects which are greater than 32 kilobytes, it will skip them. This is to speed up your migration process, and then maybe if you're having very large binary objects, copy them separately after you migrated the most of your data. And then you can go to table mapping. You map like what is the schema, what is the table name, or you want to take the same table name which is there in the source. You can just simply say a percentage, which will take the same table name as the source. And once the task is created, then what you do is you start the task, and then once a task is completed, you see that load is completed, right? Then you will see the table statistics in the DMS console, where all the table information like how many inserts, how many deletes, how many full load rows, total rows will be shown here. That way you can keep track of how the load is happening. So once by end of the data load job is completed, then you can go back and check in your S3 bucket. It should have created all these different S3 buckets. That means each bucket for one particular table which you have configured. And then you can open one of them, and then you can download the file, and you can see that the file is in this format. And as an optional, you can also configure the change data capture. That is, if something changes in the source, you want to also update the destination, right? Like something, a new record got created in your source database, you just want to update S3 data lake immediately as soon as it is that. I think you have got instructions over here. So you can start with creating the subnet groups, and then your instance, and then your source and target endpoints using the instructions given below. And then if you have any issues, please let us know. I think we'll be monitoring the chat window and questions window. Any questions? Okay, I'll leave this open for you to refer back. And then if you have any questions, please let us know.
All right, everyone. So I realize a lot of you may still be going through some of the labs. There's a lot of content to go through on the labs there. So feel free to continue those at your own pace, but we just kind of wanted to chime back in and essentially close this out for the day and just kind of do some wrap up here, give you a little bit more info about the rest of the event going on tomorrow, but a little bit more from Mission, kind of a special offer with your participation, and kind of what to expect. So, we're going to be launching a poll that we'd like for everyone to answer. And I'll be sharing my screen one last time to show something. Okay. We have a poll going just to kind of collect some info. But we're essentially offering a free 60-minute assessment with some engineers from our data team. We call it DAML internally, but we're essentially offering this assessment. We'd love to talk to your team, get a better understanding of your business and some of the objectives that you're looking to accomplish, and talk through what either solutions might look like or what services you should be considering for AWS, or if you're evaluating a migration. We just kind of would like to talk and learn any more info, as much as we can. Cool. So we good on the poll. I'm going to go ahead and kind of close out with a final slide here. Alrighty. So this was kind of just what I was alluding to regarding this, 60-minute assessment with our data team. We'd like to just help out in any way we can and just talk with either, we're happy speaking with the executive team, or going more low level and talking on the tactical specifics of what solutions and implementations might look like, scoping, going through kind of discovery sessions, whatever is kind of needed or whatever you all are looking for, we're offering this assessment for. And for those who are interested and eventually do move forward with some sort of managed service, we're offering a 25% discount on those service offerings. And so we have a wide array of services that we offer, on top of just kind of general AWS integration support and expertise. So we have expertise in like DevOps related topics, helping customers containerize application and deploy onto orchestration frameworks like Kubernetes and Amazon's ECS. We have a data team specializing in all these data warehousing and lakehouse technologies, and building solutions with this kind of some of the toolkit that we've been walking through today. And including some managed services around security and operational support. So we have an MDR service where we're always kind of providing ongoing security support and monitoring, kind of a SOC where we're helping maintain the environment and establishing logs and kind of infrastructure auditing and kind of SIM cloud-based security and reporting and governance. As well as kind of 24/7 operational support. So that's our Cloud One, our cloud operations service, where we're instrumenting the environment with our monitoring platform, deploying agents, deploying controllers, depending on the type of system that's in place, but helping customers monitor and maintain their AWS environments. Okay, and if there's any other questions, feel free to throw them in the chat. Otherwise, we're planning to meet tomorrow. Let me see. Day 2 is going to be 9 a.m. your time. So I'll be starting off with a module to go through some slide content to go further into this data lake construct, and talking specifically around some of the ETL operations with Glue. So we'll see you all bright and early for that presentation tomorrow, and we'll be going more into the labs. Have some cool ones with Glue, as well as the visualization tool QuickSight. Cool. With that, I think it's a wrap. Thanks everybody for attending today.